Thank you for joining us for the final session of the Foundations of Economic Thought open online course hosted by the Penn Initiative for the Study of Markets at the University of Pennsylvania. We hope you have enjoyed the lectures and found it intellectually enriching. The session, as always, will run for 90 minutes, beginning with a 60-minute lecture, followed by 15 to 30 minutes of live questions and answers. Please feel free to submit your questions at any point using the Zoom Q&A feature. We're happy to have Professor Jesús Fernández-Villaverde for today's lecture. He is the Howard Marks Presidential Professor of Economics at the University of Pennsylvania and the Director of the Penn Initiative for the Study of Markets. His work spans macroeconomics, econometrics, geoeconomics, and he has a long-standing interest in the history of economic thought. In this concluding lecture, Professor Fernández-Villaverde will examine the profound transformation of economics since the 1970s, driven by advances in mathematics, computing, and the changing views on policy and methodology. The focus will be on macroeconomics, tracing its evolution from the decline of the Keynesian consensus to the rise of rational expectations, the DSGE models, and the new approaches to economic dynamics. So please, Professor.
Thank you. Okay, so let me share my slides. Okay, hopefully everyone can see them. Very good. So yes, so I want to wrap up the last lecture of this course talking a little bit about the evolution of modern economics. And the point of departure is that since the early 1970s, economics has changed quite substantially. And a very simple way to do it and see the point is the following. Think about what is the premier PhD program in economics in the world. It's MIT, and it was the case both in 1970 and in 2025. Okay, yes, measuring by any type of impact factor, placement of students, etc. It's very hard to argue that MIT has not been in the leading program for the last 60 years or so. And a very nice thing about this is that actually there is a web page on the internet that puts a lot of the information about the program, including syllabi from all eras. And if you go and check the first year graduate sequence at MIT in micro or in macro or in econometrics, it does really look very different from the one you will be taking in 2025. So think about in micro, you in 1970, you will have done a very traditional Marshallian approach with supply and demand. You will have done a little bit of general equilibrium. You will have probably done a little bit of public goods. In 2025, the sequence will be very heavy on game theory, on asymmetric information, even on some behavioral issues that in 1970 were not present at all. In macro, you will have gone from doing ISLM, Keynesian models, the solo growth model, etc., to an approach that emphasizes a lot the neoclassical growth model, endogenous growth theory, real business cycle, neo-Keynesian models, etc. And in econometrics, you will have gone from dealing with ordinary least square, two-stage least square, simultaneous equation models, etc., to an approach that highlights a lot all the tools related with the credibility revolution, diffs in diffs, regression discontinuity design, synthetic cohort panels, etc. So things have changed quite dramatically at the core fields of economics, but that also goes for the other fields. Industrial organization, you will have moved from the standard structure, behavior, outcome framework to structural models of IO. In international trade, these days you will cover a lot of issues related with models of increasing returns to scale, of imperfect competition, of global supply chain, a lot of micro data on trade that didn't exist at all in 1970. In finance, this is perhaps the field that has changed the most, because these days you will be starting talking about the stochastic discount factor the very first day, and how you can think about any arbitrary asset through the lenses of the stochastic discount factor. Those type of ideas just didn't exist in 1970 at all, in development, in behavioral, you name it. And another way to check the same finding is go to the web page of any of the top 5 journals in the profession. Let's think Econometrica, or let's think American Economic Review, and check the latest issue and compare it in type of topics, methodology, and content from a random issue from the same journals in 1970. This graph is from a paper by Joshua Ancrist, and for instance, it emphasizes how the profession has become much, much more empirical. Now, over 95% of papers in development, over 90% of papers in labor are basically about empiric material. Even in micro, you are going to have that nearly 20% of the papers are very, very empirical. So that has changed a lot. And from a sociological perspective, the profession is very different. It's a much larger profession. In 1970, really top research was undertaken at a few top US departments, a few places in Europe, like London School of Economics, Cambridge and Oxford, and that was pretty much it. No one was really doing a lot of research in economics in continental Europe, for instance, except a very few isolated pockets. There was nearly nothing done in Asia. Now the profession is much larger. You go to a meeting, any type of conferences, there is 10 times more people, and it deals with many, many more different issues. So the profession really is very, very different now than in 1970. And yet, most textbooks on the history of economic thought end up with maybe Milton Friedman or someone related, or maybe a cursory and unfortunately not very deep discussion about some developments in the 1970s. Okay? Maybe there are a few textbooks that I'm not aware of that push the story a little bit further, but usually they end up in some moment in the 70s. And yet, Lucas 1972, which is a paper that I will argue later on today in this lecture, that is perhaps the most fundamental paper written in macroeconomics over the last maybe 60 or 70 years, is as far from us as it is from Keynes, the economic consequences of the peace in 1919. Okay, really, there has been nearly 53 years since Lucas published his paper. That's really, really a lot of time. And not only there is really a lot of material to cover, but it's not really covered. Most of the papers and most of the books that I have read about the topic have this general view that I already criticized the very first lecture, that the treatment of contemporary economics must be critical. That somehow the mainstream got something fundamentally wrong at its very core, and usually the author doesn't like that mainstream. Now, I'm not going to here have a very naive, Whiggish view that everything that has been developed in economics over the last 50 years is good, but I think, and I'm of course a biased observer since I'm part of the profession, that the development has been overall quite good, and that we understand many, many things much better now than 50 years ago. And what I'm going to try to do is to correct this imbalance a little bit. Now, I would love to be able to talk about micro. I would love to be able to talk about econometrics. I just don't have the time. So what I'm going to do, since this was a lot of the content of this course was related about the traditional questions on macroeconomics, is to deal with macroeconomics. Why? Well, I will say 3 reasons. First, macro is perhaps the most polemical, or if you want to use a different word, the most open to discussion field in economics, okay? You are going to see in the Financial Times, on the Wall Street Journal, op-eds talking about different monetary and fiscal policies. It is unlikely that you will see many op-eds talking about whether or not you should estimate something with diffs in diffs or with regression discontinuity design. It aligns well with the theme of the course, since we are going to be able to focus on the biographies of a few big leaders in a much more extent than in other fields that perhaps are more decentralized and have a few less like dominating figures over the last 50 years. And then from a very pragmatic perspective, because there's a field where I think we know the best. Of course, there is a fundamental question before we move on that we need to address, and which is when is something history? Okay, you could argue that history of economic thought are already the papers that were presented last week at the MBR Summer Institute. Well, that seems to push the argument a little bit. Is history of economic thought something that was written in 2010? Maybe not. So I think that in a rather arbitrary way, I will stop around 2000, just because those 25 years give us a lot of perspective about what has been influential and what has not. And because already from 1972 to 2000, there were so many and fundamental changes in the profession that we will have more than enough to fill the whole lecture. And without further ado, let me get into the core of what I want to tell you. And the first theme that I want to highlight is that technology determines ideas. So what do I mean by that? When I was an undergrad, I read this book, The Accumulation of Capital by Joan Robinson. It was recommended to me as a book that was thinking seriously about economic long-run growth, etc. And the book was written within the context of what was called at the time the Cambridge controversies in the theory of capital. And a good summary of those was written by J.C. Harcourt. And the Cambridge controversies were so called because it was a controversy between the old Cambridge in the United Kingdom, where the students of Keynes, like Joan Robinson, were located, and the new Cambridge in Massachusetts, where MIT is located, and where you had the likes of Bob Solow and Paul Samuelson. And they had different views about issues like whether or not it is possible to aggregate different types of capital into a homogeneous capital, whether or not you can determine capital within the context of the marginal, the interest rate, within the context of the marginal productivity of capital, etc. Later on, when I was already a little bit more, perhaps a mature economist, I came back and reread both of the books. And what surprised me is, and I don't want to sound nasty, but how deeply flawed both books were, okay? A lot of the complaints of Joan Robinson, a lot of the complaints of J.C. Harcourt and of the Cambridge UK are very easily handled with no problem whatsoever. For instance, if you understand about the stochastic discount factor, to be honest, I think there is absolutely nothing whatsoever left of the Cambridge critique that has an intellectual value whatsoever. But I don't want to sound nasty. The problem why Joan Robinson and Harcourt could not think about these issues carefully, and by the way, it's not that Paul Samuelson and Bob Solow got everything right either, is because they didn't have the tools to think about these issues properly. And those tools were mathematical tools. And what are those mathematical tools? The first is the development of dynamic programming, which is our ability to think about dynamic choices in a careful way. The origin of dynamic programming goes very much back in time with the idea of the calculus of variations. The calculus of variations is a subfield of mathematics that is very widely used in natural sciences like physics. You are thinking, for instance, about what is the minimum rotation time of a ball around some object. And that was developed by Isaac Newton, Joan Bernoulli, like think about the Bernoulli equation, Euler, of course, of the Euler equation, and Lagrange from the Lagrangians. This calculus of variations was okay and it worked fine for a long time, but in the 1930s and 1940s, people in applied math started realizing it didn't really handle very well more complicated dynamic optimization problems. And in particular, this realization came from aerospace engineering. And the typical problem that people realized that they were very interested in solving and they could not really solve with the standard method was the minimum time interception problem for fighter aircraft. So, think about yourself. You are in 1939, you are the United Kingdom. You are very concerned about how to set up a defense against incoming German bombers in World War II. And what you want to do is think about where to locate the Royal Air Force bases in such a way that you optimize the time that the fighter aircraft can actually intercept an incoming bomber. Well, that's just a dynamic programming problem, and it turns out to be the case that it's impossible to do with calculus of variations, or so cumbersome that in practice is impossible to do. And during the Cold War, there were many related issues. And that meant that there was a very big interest both in the Soviet Union and in the United States to develop the mathematical tools that will be able to help us to think about these issues. In fact, it's really funny because in the late 1950s, in the same way that people at the time were talking about the missile gap between the Soviet Union and the US, there was some concern in the US that the US was falling behind in the ability to build missiles. There was a concern about the optimal control gap, that the Soviets were getting so much better at designing systems of optimal control over time that the US risked falling behind. On the side of the Soviet Union, we have Pontryagin and his students. You have over here their photographs. Pontryagin, very interesting life. He got blind when he was a small kid because of a kerosene lamp fire accident. Developed the maximum principle, which is basically the idea that the solution of an optimal control problem needs to satisfy a Hamiltonian. The Hamiltonian is kind of brings from the context of Hamiltonian dynamics, of course, in physics, but it turns out to be the case that it helps us to set up problems of dynamic optimal control in a very convenient way. On the side of the US, we have Hestenes, Isaacs, and of course, Richard Bellman of the Bellman equation. And these three were the leaders of the developing of what we call today dynamic programming, and all of them were centered around RAND, which, as you probably know, was a think tank financed by the Department of Defense in the United States. Bellman is one of those geniuses that come once every generation, and in particular, he was the main force behind the development of three fundamental ideas that are still at the very core of economics today. First, the distinction between control and state. What is a control variable? It's the type of variable that you need to control, as the name indicates, that you need to manipulate to achieve your goal. What is a state? A state is the set of variables that summarizes the situation of the dynamic system. Clarifying the difference between a control and a state was very, very important. And even if it seems obvious to us, coming back to my point, you read Joan Robinson, she is not clear about that at all. They develop also the principle of optimality that says that an optimal path is made of optimal steps. And why is this so important? Because it helps us to divide the problem of dynamic programming between the optimality of one step and the optimality of the rest of the problem going on. And that leads very naturally to the formulation of a Bellman equation and the modern dynamic programming. All these type of approaches, precisely because this difference between the control and the states and solving something today and the continuation value tomorrow, became very soon known as recursive methods. Other similar recursive methods were things like the Kalman filter and in general all modern filtering theory, which also have a very similar structure. In fact, you can show that any filter is the dual of any dynamic programming problem. They are just the same mathematical object, look at it from different perspectives. Interestingly, this is a situation where I think there is next to no literature written on these issues. The only book I could find was by Michael Plale, is in English, which is on the development of optimal control theory. Over here you can see that English and German actually share a common origin, because over here you can see a steer, Stierungen, steer, as steering a wheel in English. So if anyone will be interested in writing a dissertation on the development of dynamic programming and how dynamic programming influenced modern economics, I think that's a dissertation that is waiting to be written, and it can be a very, very nice monograph. Now, the other aspect that was developed and that complemented dynamic programming, of course, was the development of our ability to think about stochastic environments in a formal way. And this is particularly relevant when you actually mix probability or stochastic environments with dynamic environments. Of course, we all know that differential calculus was introduced in the 17th century by Sir Isaac Newton and Leibniz, but it's only in the late 19th century and in the early 20th century that we understood how to extend this differential calculus to environments that were stochastic. And this is what today we will call stochastic calculus. The ideas go back to Thiel and Albert Einstein that introduced the idea of a Brownian motion. And basically what both Thiel and Einstein were thinking about are physical models or chemistry models, for instance, models for the motion of small particles suspended in a liquid. You take a glass of water, you put some small particles, and you look at how those small pieces of dust move in the water. That's a Brownian motion. turned out to be the case that even if that was developed for technical problems in physics, it was very soon apparent that you could apply the same ideas to asset pricing. And the pioneer work over there was by Louis Bachelier that applied to the stock market in France. Unfortunately, Bachelier's ideas were largely overlooked for several decades, and his dissertation was forgotten until Paul Samuelson rediscovered it. Norbert Wiener, a little bit later, used the ideas of measure theory, which, as you know, is the field of mathematics that is involved with a careful and formal treatment of probability to construct measures on the path space of continuous functions, which is what you need to do to have a possibility to talk about the stochastic processes formally. And that was, of course, extended by people like Andrei Kolmogorov of the famous Kolmogorov forward and backward equations, which are at the very core, for instance, of much of my own research. Wolfgang Dublin, that introduced the modern treatment of diffusion with a change of time, and finally with Kiyoshi Ito that introduced the Ito's lemma, probably the most important result in stochastic calculus and the foundation of much of what we do every day in economics, at least in macro. Okay, few things are more important than the Ito's lemma. And the combination of having dynamic programming and stochastic methods has led to what Tom Sargent has called the imperialism of recursive methods. This is a screenshot from the table of comments of his enormously influential, and I will dare to say even canonical, book on recursive macroeconomic theory with Lars Lundqvist. And you can see how he explicitly talks about the imperialism of recursive methods and how he basically formalizes the full of modern macroeconomics around them. And again, this will be totally different from what you will have done before. I don't know how many of you have done the following exercise. I actually have done it. I went around and figured it out looking in some archives or looking in some old syllabi, which were the standard textbooks that people were using in macroeconomics in the 1960s. So for instance, you had a very famous book by Allen, who was at London School of Economics. There was another one by Branson a little bit later in the early 1970s. Patenkin in Money and Prices. And if you read those textbooks, they really do not look at all as anything in Lundqvist and Sargent, basically because you can tell they don't know how to deal with dynamics. And the reason they don't know how to deal with dynamics is because they did not have these recursive methods. Okay, so the point I'm trying to highlight and emphasize here in a dramatic way is because we change the math, we change the type of problems that we deal with, and we change the way about how we thought about those. Okay, very good. So then, after this brief background on the development of modern math, we can get into modern macroeconomics. But just let me make a small obiter dicta, a small side remark. Sometimes I see people saying, oh, my favorite economist, I don't know, let's call him Maynard Keynes or Murray Rothbard. Guess what? They actually study math as an undergrad and they don't like the use or the current use of math in economics. My answer is, you don't even know what you're talking about. And the reason is both of them study math before the 1950s, where all the tools that we use were not even invented. So nearly by definition, they didn't know anything about modern math, and hence all their thinking about the issue is completely useless. Let's get into modern macroeconomics. The late 1960s and the early 1970s were a difficult time for macroeconomics. There was a growing uneasiness with the so-called post-war Keynesian consensus. And this was both theoretical and empirical. Let me start with the theoretical unhappiness. Keynesian models, in particular, the very large models used by the central banks, like the Federal Reserve Board, MIT, Penn model, lack tight theoretical foundations. What do I mean by that? Okay, so this is the very, very basic model, the very, very basic neo-Keynesian model that, for instance, you will have seen in Klein 1, okay? Larry Klein, who was a professor here at Penn, and I overlapped with him for a few years, basically makes an enormously important contribution And I have nothing but deep admiration for him because he says, look, you read the general theory and you are going to be able to come up with a relatively straightforward set of equations. You know, you are going to have the consumption equation or the consumption function where consumption depends on output. You are going to have an investment function that depends on the interest rate and output and some other things. You are going to have, and those two are going to give you the IS because it's going to give you the equivalence or the interest rates that give you an equivalence between savings and investment. Then you are going to have a money demand function that is going to depend again on issues like output and the interest rate, and that give you an LM. And the IS and the LM together will give you the aggregate demand. On the other hand, when you put together a production function and some type of equations or functions determine the labor demand, you will get the aggregate supply. And the intersection between the aggregate demand and the aggregate supply will determine output. Now, most of these models actually put much more attention on the aggregate demand, and output was largely demand determined, not supply determined. But while the first generation of models was simple and straightforward, the logic of the literature was to make things every time more complicated. You know, you have made a model with 1, 2, 3, 4, 5, and 6 equations. Well, the next generation needs to have at least 7 equations, and the next generation is to have at least 8 equations. And that's what is going to happen. You are going to go to the Klein models 2 and 3, and then to the Klein-Goldberger model, and the Brookings model, etc. And what will those things do? So for instance, you take over here the consumption function, and you are going to say, well, I have a consumption function for all goods and services. Let me divide it between a consumption function for non-durable goods and a consumption function for durable goods. An investment function, maybe let's have an investment function for structures and an investment function for equipment because they may respond to different type of variables. And before you realize you are in a situation like this one, for instance, the Brookings model, where you have this enormously complex setup that made the model nearly impossible to understand. And moreover, while Keynes in the general theory may have had some insights about what we need to put in the consumption function, who knows what you really need to put when you are thinking about the business inventories and how it relates with the changes in inventories, orders, investment. Okay? And that made people very, very unhappy. They say, well, what are these models for? This is so complicated, no one understands them. In fact, the models became so complicated that researchers even constructed surrogate models to replicate the behavior of large-scale models. So I know someone, Tim Conley, that told me that this was exactly his very first job at the Federal Reserve System. Running the model, the FRB MIT Penn model, was so complex and so time-consuming that they will run the model, simulate data, and then estimate a model on the simulated data from the model, and then work with a much smaller model. Surrogate models have some uses, and for instance, now they are popular again in the context of machine learning, but for a very different reason. The moment where you cannot even use your model to think about the world, you know that you have done something wrong and that you need to rethink what you were doing. There were also concerns about how to deal with expectations. As dynamics became more and more prominent, people started saying, well, this investment function may depend not on output today, but also on output tomorrow. Then how do we think about those expectations? And macroeconomists started to care about micro foundations. And the reason was very straightforward. Is look, how can it be that what we do at 9 in the morning, which is the introduction to microeconomics class, is so different from what we do at 10:30, which is introduction to microeconomics? We want both ways of thinking about economics based on the same type of fundamental principles, which is to look at preferences, technology, and information. And the only way you are going to be able to do that is that there is actually a tight micro foundation of micro within macro. This the very same logic of how you think about economics very, very quickly takes you to the micro foundation. In terms of the quantitative problems, the first and fundamental was that stagflation, that is the combination of high inflation and output stagnation that most Western countries, in particular the US, experienced in the early 1970s, did not sit very well with the standard Keynesian narrative. Standard Keynesian narratives highlight the importance of demand in determining output, which basically means, which basically means that when inflation is high, you are going to have high output, and when inflation is low, you are going to have low output. Now, fair enough, the models also have a supply shock, and you could think about shocks to the supply part, like the oil shocks of 1973 and 1979. But the attention that had been put to the supply aspect of the model was very limited. And in general, most people felt that the answers of, oh, we just had some supply shock were a little bit ad hoc. But even more important was the realization that these very large and complicated models actually didn't do a very good job at determining national income or any other variable of relevance. Charlie Nelson, in 1972, publishes an enormously influential paper, The Prediction Performance of the FRB MIT Penn Model of the US Economy, and basically shows how to use very, very simple and straightforward ARIMA models, autoregressive integrated moving average models, is going to allow you to forecast better than this extremely complicated model. And that means why in the world you have spent so much time, effort, and resources on trying to fix them. So people were unhappy. People were basically saying the macroeconomics that we have, let's say 1970, doesn't seem to work. Doesn't seem to work theoretically. There seem to be lack of tight identification assumptions. There seem to be a lot of contradictions inside it, but it also seems to be failing and explaining the data. And economists took different ways to address it. Now, if instead of just 90 minutes, I had 3 days, I could tell you about many different routes. Some of them, in fact, were highly promising and we abandoned them, and perhaps we need to return to them in some day. One of the guest lecturers talked, I think 2 weeks ago, about disequilibrium models. Yeah, maybe one day we need to talk about those disequilibrium models again. But the punchline is that the agenda that was the most successful was the rational expectations revolution. And over there, you have Bob Lucas, Tom Sargent, and Neil Wallace. I'm going to follow the convention that I'm going to cite birth and death rate for those who have already passed away, but not for those who are still alive. Most of this rational expectation revolution is associated with the University of Chicago and with the University of Minnesota, where I studied myself. Tom and Neil were for many, many years at Minnesota. Lucas was never formally affiliated with the University of Minnesota, but spent much time at the Minneapolis Fed, at the Federal Reserve Bank of Minneapolis, which has a very, very tight relation with the University of Minnesota Department of Economics. And that's why sometimes this is also called freshwater economics, because this is supposed to be by the Great Lakes. In the case of Chicago, the many lakes of Minnesota, although, to be honest, I always thought that that was a slightly silly way to refer to this school or this approach to macroeconomics. Unfortunately, and I'm going to be very open about what I feel about this is a topic where most monographs are really bad. You take your standard book, and I'm not going to cite any of them. I don't want to, make any enemies in a gratuitous way. But if you take your standard book that tries to narrate the rational expectation revolution, it's really quite awful. It's really quite awful. Part of it is because there is a mix of politics. Some of the early results of the rational revolution, of the rational expectations revolution, imply that there were many more limits at the ability of fiscal and monetary policy to stabilize the economy that the traditional Keynesian approach suggested. And that was associated at the time with more conservative positions, where at the time conservatives thought that government should have less of a role to play in the economy. I guess that now that we have very active conservative governments, that sounds kind of paradoxical, but that was the case. And despite the fact that at a personal level, the politics of many of the leaders of the rational expectation revolution was certainly not conservative, however, somehow rational expectations became associated with that conservative position. And many of the critics, since they are not on the center right of the political spectrum, just brought that background into the discussion. I think there is also a fundamental problem about lack of understanding. So I think that part of the reason why history of economic thought has become much harder is because just trying to understand what people is saying is much, much harder. I was mentioning before Allen as a standard textbook of macroeconomics in the 1960s. A good undergrad can work through Allen. Okay? No problem whatsoever. You just sit him or her in front of Allen and it will be able to figure it out 95% of it on her own. If I give an undergraduate recursive macroeconomic theory, it's going to be very difficult that she will get all the points. And even myself, I often go back to my lecture notes from Tom. I took a class with Tom, and I still find insights that were missed by me when I was in real time taking that class, and I have needed 25 years to mature on them. So for an outsider who is not really an expert on the field, suddenly it's much, much harder to judge that in the past, just because you need so much knowledge that is very, very difficult. And finally, because I think there is a penchant for teaching the controversy, for, somehow putting on one side, as I was saying, Chicago and Minnesota, on the other hand, Harvard and MIT, that sounds great. You make a great article for the economists, it's very interesting. Undergraduates love those type of ideas, but at the same time, I don't think really this is a very good description of how many times the literature evolves. So, what was behind this rational expectations revolution? Well, as I was mentioning before, that people like Bob Lucas started taking dynamics very, very seriously in the 1960s. Lucas, and now we are going to talk about biographies, and I'm going to talk about not only Lucas' biography, but myself. Since I talked with Bob, I was very fortunate to have spent quite a bit of time with him talking about these issues. Bob was very interested in growth theory and business cycles. And he felt that the tools he had at the time were insufficient to deal with these issues. And he actually took 1 year off from the frontier of research to study functional analysis and recursive methods. Functional analysis is a subfield of analysis in mathematics that deals with the space of functions. And when you are dealing with objects like the Bellman equation, that's the type of environment in which you are working. And Lucas, and later on people like Nancy Stockey and Ed Prescott, that brought together recursive methods in macroeconomic theory, the blue book that has been so influential, really felt that they needed the time to learn these issues. It's kind of interesting because these days, since we have spent time on them and we have distilled them, I can really, when I teach my first year macro class, I can really kind of give the absolute nuggets of what is really, really important to know about these methods. But around 1970, it was very difficult to figure it out, what was useful, what was not useful, even the right notation. So Lucas and his co-authors spent a lot of time trying to bring this into the table. And that led to questions, which I'm going to come back in a second. But an interesting point is that this is going to make a big difference with respect to the tradition of Milton Friedman. What people forget is that Milton Friedman and people in the monetarist tradition were the low math people, okay? Friedman's mathematics are very simple. You look at most of his papers on his book, so there is nearly next to no math. Most arguments are verbal, or maybe he has some diagrams, but there is very little math. The high math persons were the Keynesian economists at MIT. If you were into, let me write a really super sophisticated model with a lot of math, you go to study with Paul Samuelson at MIT. You don't go to study with Milton Friedman in Chicago. And in fact, people associated at the time very high brown mathematics in economics with being very much on the left of the political spectrum, because people like Ken Arrow had developed models of general equilibrium to understand a market economy precisely because they wanted to replicate it through a socialist economy. Someone that I know, Michele Boldrin, told me once that when he arrived to UCLA, where there are people like Armen Alkian and Bob Allen, the first thing they asked him, oh, you're a mathematical economist. That means you're some type of a communist, which is not the case for Michele Boldrin. And that kind of shows you that that question kind of made sense 25 years ago, maybe 40 years ago, but not today. And that's why I just couldn't help it. But I saw this tweet the other day on July the 6th, William Ho, but what talks about Friedman's clean math is easier to sell. And he's complaining about the state of modern economics, where that just tells you how clueless this person is. And how when sometimes people say that math somehow is one type of economics versus the other, it's just, no, these things change over time. And by the way, that's why, and some other reasons, calling rational expectations monetarism too. I remember when I took an undergraduate course in history of economic thought, that's how my professor called it, monetarism Mark II, is beyond silly. In fact, Bob Lucas and Milton Friedman didn't have a very good relation, and Chicago only hired Lucas when Friedman was not influential then anymore. They really thought about the world in very different ways. Okay, So why does Bob Lucas bump into the idea of rational expectations, which is not originally his, is by Booth? And it's because of a very simple situation. Imagine that you are in a situation in your model where, for whatever the reason, you or the agents in the model need to compute the expectation conditional on time t, that is the information set at time t of xt plus 1 of some variable tomorrow. Why? I don't know, you're solving a dynamic programming problem and you need to care about what output is tomorrow. Or you need to solve an optimal consumption saving problem and you need to care about what your income is going to be tomorrow. So what is the best approach to do this? How do you compute this expectation? Well, there are basically three ways to do it. One is to have some type of an ad hoc rule. And for instance, you can use perfect foresight, where the expectation today of the variable tomorrow is just the value of the variable tomorrow. That's, for instance, what Allen does in his textbook that I keep referring to. What is the problem? Well, you are killing anything that is related with stochastics. You are not really thinking about shocks in any meaningful way. And as I mentioned before, we really want to talk about shocks. We want to think about uncertainty. We want to think about the economy fluctuating in random ways. Okay, what is the second thing you can do? Well, maybe you can do some type of adaptative rule, where you say that the expectation tomorrow is some type of moving average of past expectations, of past realizations of the variable. Well, this has two problems. This may not be a bad approximation of how people build their expectations in many contexts, but there are many situations where that's not true. I don't think that the day after Donald Trump wins the election, people thought that the way he was going to behave was basically Joe Biden with a small difference. People thought, no, this is a change of regime, things are going to be different. But more importantly, what you have over here is a lot of discretion about how you set up this adaptative rule. And what people realize very soon is that small differences in the details of the rule led to very, very big differences in the outcomes of the model. And people were very unhappy about that. It's very unsettling that your model depends on somewhat minor auxiliary assumptions. So the third thing that you can do is to use a rational expectation. And the only thing that a rational expectation says is that your expectation of a variable tomorrow needs to be equal to the value of the variable tomorrow plus some difference that needs to be orthogonal to any existing information set. That there can be nothing that you can use to minimize or to reduce epsilon. Okay? This is nothing more than a standard assumption in economics, which is you are rational and you are trying to use all the tools that you have around to do the best, to do as well as you can. Now, this doesn't imply that Lucas thought that people are perfect robots that always get the future right. Not at all. In the same way that he didn't think that people always make the right decisions where they are trying to decide, should I eat more oranges or should I eat more bananas? No, what he says is, look, in a standard model in economics, we assume that people are making the right choice between oranges and bananas. Let's make the same assumption, which is model consistent, about their ability to forecast the future. They are not going to get it right, but they are not going to have biases that can be exploited in some way or another. And he made this argument in several papers, but the one that is perhaps the most famous and the most deeply influential is the Lucas 1972 paper that I was mentioning before, Expectations and the Neutrality of Money. He was at Carnegie Mellon at the time. Remember, he had not moved to Chicago because Friedman was not very happy with this type of research. And what he shows over there is that in a model like that, you are going to be able to generate business cycles even in a condition where you have these rational expectations. That is, you can have business cycles in equilibrium, and that was an enormous influential result. People realize that to talk about random shocks and to talk about stochastic fluctuations, you could still do it within the context of a standard economic theory, and you did not need to add ad hoc shocks like you needed to do in the traditional Keynesian models. In the traditional Keynesian models, you will say, oh, I have this supply curve, let me add a shock to it. And everyone was like, why? Lucas say, no. actually you can build a dynamic model where fluctuations are endogenous objects. And that's why this was so immensely influential. This is what I will argue. This is the most important paper for sure in macroeconomics since 1945. As I was mentioning before, rational expectations imply that expectations are model consistent, which is great. You don't want to have models where the behavior of the agents is not consistent with the premises that you make. And also it minimizes pre-parameters. You don't have all these lambdas floating around that you don't know what to do with them. We like that, okay? Again, quoting Tom Sargent, beware of theories bringing free parameters. Free parameters open the door to do whatever the economists want. And something that you really, really want to understand is that the fundamental problem of economics is not that it imposes too many restrictions on the data, but that it imposes too few. This is the type of theorems that we know in general equilibrium, like the de Broglie-Mantell-Sonnenschein results, or in dynamic economics, the Boldrin-Montruccio model result. Basically says that anything can happen. If you give me complete freedom with respect about how people have expectations, how people have preferences, and what type of production functions people have, I can explain anything. There is no set of data that can be validated, that can be not validated by a model. So what we try to do is search for models, for ways to restrict the free parameters in our models. And that's why rational expectation is so useful. It says, I'm not going to give you degrees of freedom as a researcher. You need to get a good answer without me being able to cheat by picking whatever expectation process I want. These models also create a communism of expectations, which is nice because it basically says everyone fundamentally agrees about the model in which they live. Later on, this will be relaxed, and there is a sub-area of economics where people have different expectations about the future, and that's actually super interesting because you then need to have an expectation about what the expectation of the other person is. This is forecasting the forecast of others' literature, super interesting field, but having a baseline scenario where there is a communism of expectation is the first step that you need to have to be able to build a model of forecasting the forecast of others. And as I was saying before, then what happens is people say, look, this rational expectation assumption is a very, very nice and fruitful way to think about the world. And how can we justify it? And I will say there are three possible ways to justify it. One is convenience. Okay, so if you talk with someone like Bob Lucas, this is the one he liked the most. He will just say, in the same way that we assume that people, as I was mentioning before, pick between oranges and bananas in an optimal way, we are going to assume that they build expectations in a rational way, and we can see how far away we can get on with that assumption. And what I'm going to demonstrate to you is that I can really get very far away. I get really deep insights about the behavior of the economy, and that's what makes this assumption good. There is a second possibility, which is to justify based on learning by agents. It is true that people may not be perfect automatons that understand everything in the model perfectly, but they may be sufficiently sophisticated that they can learn. And there is a whole literature about that by Evans and Honkapoya. Summarized it a few years ago, Learning Expectation in Macroeconomics. It's a very nice book. It's already 25 years old, but it's still, I think, a very good entry point into the field. And finally, and to me, to be honest, is the most compelling argument. In an equilibrium outcome, only the marginal sophisticated agents matter. So yes, it's probably true that the median person is not very smart. It's probably true that the average graduate student in anthropology gets every single fact about the planet wrong, but it doesn't matter because the graduate student in anthropology is not the marginal agent determining prices. Who is the marginal agent? Cliff Asness, the founder of AQR, one of the largest hedge funds in the world. He is the one determining prices, and he has spent a lot of time and effort into getting this right. And that's one of the main lessons of general equilibrium. There's a lot of idiots in the world. Turns out to be the case they don't matter for general equilibrium outcomes. If you want to learn more about this, Tom Sargent has this wonderful memoir called Learning from Lucas that just got published a couple of years ago. It's very nice. I don't know if you can find a video of him giving this paper, but when he gives the paper, it's actually hilarious because he always uses jokes and actual real anecdotes that happened to him at the time. And it's really interesting. But this is a great paper. It will really get the feeling about exactly what was happening. You can see over here, Sargent, Lucas, and Wallace, which is exactly the three people I was having over here, and how they were the leaders of the rational expectations revolution. But what are the consequences of rational expectations? Basically, there was never a better time, I think, to be a macroeconomist than to be around Minnesota or Chicago around 1974, 1975, because now that you have rational expectations, you have, and the modern tools of dynamic programming, you can basically rebuild the whole of economics, the whole of macroeconomics. It was just kind of write one paper after the other. So let me tell you a few of the ones that I think are the most interesting or the most relevant. The first one is the so-called Lucas critique, econometric policy evaluation, a critique. It came up at the Carnegie Rochester conference volume. And Lucas builds on an old idea by Yakov Marshak, a very famous economist from the Coles Commission era, that had made a point that was to some extent understood, but also to some extent forgotten. And is that you cannot use past data to forecast future behavior if you change the policy that agents think you are following. And let me give you a very simple example of what I'm going to call the four knocks problem. Okay, so what is the four knocks problem? The four knocks problem, you know that Fort Knox is the place where the US keeps its gold reserves. Okay, and you can pick whatever central bank of gold deposit you can imagine, and you put over here on time the amount of money that the US has spent on safety measures at Fort Knox, and you put also the number of gold stolen from Fort Knox. 0. No gold has been stolen from Fort Knox. Consequence, spending all this money on Fort Knox doesn't have any impact because we are spending now much more and we have 0 gold stolen when a few years ago we were spending much less and we also got 0. Of course, all of you will conclude that that's a silly consequence, a silly inference, but that's exactly the point that Lucas was trying to say. People don't get into Fort Knox because we spent a lot of money into Fort Knox security. But life will be very different if we didn't spend that money. And what Lucas tried to argue, hence, is that a lot of the things we constantly make, or a lot of the policy recommendations are very fragile because they depend on people thinking that we are going to keep using the same policy as before. A second very important consequence were the early results on the irrelevance of monetary policy. So for instance, this very, very famous paper by Tom Sargent and Neil Wallace, Rational Expectations, the Optimal Monetary Instrument and the Optimal Money Supply Rule. And what you see over there is basically that once you take seriously the fact that agents can anticipate monetary policy changes in the future, the effectiveness of monetary policy is going to be much smaller. And by the way, this is the origin of a lot of the popular misconceptions about the policy implications of rational expectations. Since one of the very early papers and most influential was, guess what? It turns out to be the case that you don't really have much of an effect on monetary policy doesn't have much of an effect on output, then it needs to be that rational expectations on how is, against stabilization policy. Turns out to be the case, this is a very, very fragile result, okay? It's a result that gets completely thrown away as soon as you, for instance, introduce nominal on real rigidities. It's not at the very core of rational expectations, is really an auxiliary consequence of having models without nominal and real rigidities. Other type of consequences you had from these models. For instance, you had Ricardian equivalence. Again, Ricardian equivalence is one of the most misunderstood results out there, so let me be very careful stating it. The idea was introduced by Robert Barro in his famous paper, Are Government Bonds Net Wealth? After he started talking about these ideas, apparently James Buchanan, who was at the time at Virginia, told him that David Ricardo in the 1820s had already talked about this idea, and that's why it became known as the Ricardian equivalence, although paradoxically enough, David Ricardo didn't really believe in it. So what are we dealing with here? Ricardian equivalence states that once you have fixed a path for government consumption, okay, this is very important. You have a path for government consumption that is already fixed. Okay, so you have G, and G is fixed. Then whether you are going to finance G with taxes or whether you are going to finance G with government debt does not matter. Ricardian equivalence does not say that changes in G do not have an effect on output. Of course, changes in G have an effect on output. What it says is that if you do it with taxes or with bonds, now taxes need to be lump sum, I will come back to that in a second, you are not going to have a different allocation. Now, lump sum taxes, you do it in that way because they don't have distortions. If you have distortionary taxes, yes, there is going to be a second order effect of changing the taxes today versus changing the taxes tomorrow, but that's going to be a secondary order effect. And what really was relevant is that it turns out to be the case that Ricardian equivalence is part of a much more general result called the Modigliani-Miller irrelevance theorems in public finance. Let me give you a little bit of background. Modigliani-Miller, probably of you already know, is a set of results in corporate finance that say that the value of a firm is equal to the present discounted value of its future cash flows. You know, what else can it be? Fine. But a consequence of that statement is that whether the liabilities of the firm are financed through debt or through equity does not matter for the total valuation of the firm. Okay? It's an irrelevance theorem. It says it doesn't matter how you finance your firm. What matters is how those discounted cash flows are allocated between debt holders and equity holders. It's only about who gets their pick first. The bond holders get the cash flows first, and whatever is left goes to the equity holders. It's just about the order of receiving a payment. Well, it turns out to be the case that there is a very large class of monetary policies, tax policies, and bond policies, public debt issuance, such that we manipulate changes in M with changes in T with changes in B, and the allocation of price and quantities does not change. Okay? And the first person who realized this enormously important result, this equivalence theorem or irrelevance theorem, is again Neil Wallace. A Modigliani-Miller theorem for open market operations, American Economic Review, 1981. Again, an absolutely path-breaking and fundamental paper. This paper, for instance, says that quantitative easing is irrelevant. Quantitative easing, the way it was implemented by the Federal Reserve Board, not the first round, but the second and the third round, is the Federal Reserve Board is exchanging some type of government debt, which we call fiat money, for other type of government debt, which we call nominal bonds. And it basically is telling you that's irrelevant. It doesn't have any impact. 2011, I actually, when the US started its second round of quantitative easing, I wrote about that. And I say, there was a lot of people saying, oh, there is going to be hyperinflation, there is going to be such a big changes in prices. And in 2011, I say, no, quantitative easing is not going to have any impact, neither good nor bad, or at least any first order impact. The real world is always a little bit more subtle, and there are like second order effects because markets are not perfect. But by and large, quantitative easing is going to be irrelevant. Why? Because I have read Neil Wallace. And by the way, much follow-up work that came after Wallace. You cannot imagine how much hate email I got after that one. And I tried to explain the relevance theorem to some of my friends in the financial market, and they will just not get it. And they will say things like, oh, but there's going to be a lot of inflation in 6 months. Inflation didn't come. They will come to me and they will say, oh, why there was no inflation? I will try to explain the theorem and they will not get it. And will say, no, the inflation will come in 6 more months. And of course, it didn't happen. Inflation never came in the 2010s because of quantitative easing. Inflation came later on because of what I'm going to tell you in a different moment. But it turns out to be the case that behind these Modigliani-Miller theorems, there is an even more general way of thinking about the world, which is the fiscal theory of the price level. And who really created the fiscal theory of the price level, again, are Sargent and Wallace, and again, both of them were at Minnesota at the time, with their extremely famous paper, Some Unpleasant Monetaristic Arithmetic. And if I were going to select one paper that completely changed the way in which I think about the world, this is the paper. Because this is the paper that says at the end of the day, you cannot think about monetary and fiscal policy as two different types of policies. They are just the same type of policy in different ways. In fact, Maynard Keynes already knew this. In a famous passage in The Economic Consequences of the Peace, he jokes that when an Englishman pays his taxes, he gets a receipt from Inland Revenue and throws it away. When a French pays his taxes, he calls it bonds and puts it in the family safe. And when a German pays his taxes, he calls it fiat money and puts it in his wallet. That is, at the end of the day, to spend is to tax, and you can tax either with fiat money, with bonds, or with taxes, regular taxes, and there needs to be some non-arbitrage condition between the three of them. And by the way, that's why at the end of the day, traditional monetarism doesn't really make any sense whatsoever, because it completely ignores these fiscal theory implications, and why the quantitative theory of money and the quantitative theory of the price level doesn't really make a lot of sense as soon as we have fiat money. Of course, it still makes a lot of sense if we are thinking about commodity model, money like gold and silver, but once you are in a world of fiat money, using the quantitative theory of money confuses more than helps, and that's why all my friends in the financial sector were so confused about quantitative easing in the 2010s. And if you want to read about the fiscal theory of the price level, John Cochran, a good friend, just published a wonderful, wonderful textbook on it, where you can understand everything that is done in that field, an area that we are still trying to figure it out, some of the details. Other consequences we got from this area. So for instance, we learned to develop the so-called modern overlapping generation models. And in this type of models, what you are going to have are generations that live for different periods. So you are going to have one generation that lives for these periods, then you are going to have another generation that is going to live for this time, and another generation that is going to live for those years, and so on and so forth. Why these are models extremely interesting? Whenever I teach first year macro, I spend quite a bit of time talking about them, because it's really a canonical example of an incomplete markets model. Basically, generation 0, let me write generation 3 so it's very clear. Generation 0 cannot trade with generation 3. Okay, so the best way to think about overlapping generation model is as a model where some markets are closed. I cannot trade with someone who hasn't been born yet. Okay, the same way that I could not trade with someone who died before I was born. And once you have incomplete markets, a lot of interesting things are going to happen. For instance, you are going to have fiat money that is value in equilibrium. You are going to have bubbles that are value in equilibrium. You are going to have a lot of inefficiencies. You are going to have a lot of interesting dynamics. And also, that was the origin of a lot of quantitative analysis, because this type of overlapping generation models is the perfect way to think about issues such as social security or intertemporal finance. Let me give you a little bit of books, a very nice survey of overlapping generation models was just published recently by Stephen Spear and Warren Young, Overlapping Generations, Methods, Models, and Morphology, and a very influential book. It's a little bit old now, but it kind of show you in how these overlapping generation models were taken very seriously for policy considerations is by Aulan Auerbach and Lawrence Kotlikoff. Now, since you have these different generations, people started thinking also about the possibility that agents are heterogeneous. Okay, instead of having a representative agent like most models in macro had in the past, people started to work very, very seriously on having models with heterogeneity. And this was really at the very core of a lot of the research that was done in Minnesota starting on the late 1980s. You had those models were pioneered by Truman Whaley at Yale, but then the person who really pushed them was Rao Ayagari. And after Rao Ayagari, who sadly died very soon, very young, you have Mark Uget, Eishai Mororoglu, Victor Rios-Rull, Per Crusell, and Tony Smith. And over here you have a photograph of Rao. You have, of course, Eishai Mororoglu, who did a lot of very pioneering work very early, and the use, of course, of microdata, because those were models where you were going to be able to integrate microdata with macro aggregates because you have this heterogeneity. Of course, everything was done around Minnesota. I'm taking this from a blog post of a friend, Beatriz, and the paper that perhaps has been the most influential in this whole area is Income and Wealth Heterogeneity in the Macroeconomy by Per Crusell and Anthony Smith. I remember arriving to Minnesota as a first-year graduate student. The paper had just circulated as a working paper, and there was really a lot of excitement on the air about how this paper was going to completely transform macroeconomics, and I will argue it has done so. And most of my research, for instance, my job market paper is exactly about that. It's about heterogeneous, it's a model with heterogeneous overlapping agents in an overlapping generation setup, and much of my research. I just presented a paper like that last week at the MBR Summer Institute, precisely comes from this tradition that Rao and Asia and many other people open. Other consequences that were very important were, for instance, that for the first time, now that we could deal with dynamics, we could in particularly deal also with ideas like time inconsistency. And what do I mean by time inconsistency? Well, it turns out to be the case that just because you have a dynamic plan that is optimal, you may not be in a situation where you may want to change that plan if you don't have access to a commitment device. What do I mean by that? Well, think about the following possibility. A government that wants to finance government consumption could do the following. It could say, I'm going to impose a very high levy on capital today. That's not distortionary because capital has already been invested. There is nothing you can do about it. And then I'm going to use the proceedings from that levy on capital to tax labor in the future less, which will reduce distortions, and I'm going to promise never to tax capital anymore. That's actually the optimal solution. That's called the Ramsey solution to this problem. Turns out to be the case that you probably have figured it out that in the absence of a commitment device, and probably there are not enough commitment devices in the real world that are really credible, you are going to have an incentive as a government to cheat. In every period, you are going to say, oh, this is the last period where I'm going to tax capital. Starting tomorrow, I'm not going to tax capital anymore. And of course, that leads to agents understanding that you are going to do that every period. And at the end, the total allocation is going to be, the final allocation is going to be awful. And the paper that made that point was Finn Kidland and Edward Prescott, Ed Prescott, Rules Rather Than Discretion, This Consistency of Optimal Plans. And basically what they were saying over there is rules are better than discretion precisely because discretion suffers from this problem. So if you can implement rules, please have those rules. This paper is from 1977. And that created a lot of important research follow-up. In the interest of time, I'm going to skip it. And the last consequence that I want to talk about is that the old way in which we were doing econometrics suddenly is completely antiquated. You want to build a new type of econometrics that can deal with rational expectations, and in particular, where you have the cross-equation restrictions that are the hallmark of rational expectations. What do I mean by that? If you go to the old models by the people like Klein, you see you have a y over here, and there will be a y over here, and then will be a y over here. But in any way, it was never imposed that agents fully understand that there needs to be cross-equation restrictions implied by equilibrium and market clearing conditions linking all of them. If you try to impose those conditions, the econometric problem becomes much, much harder. Okay? And in addition to it, we are in a situation where we fully understand that the models are false. Okay? People were fully aware that rational expectations is just a good way to think about the world. It's not quote unquote the truth. And that all models are false, but some are useful. And you want to develop ways to think about false models and yet being able to take them to the data. And for instance, that led to very important issues like the two-volume collection, Rational Expectations and Econometric Practice, issued by Lucas and Sargent, that was very, very influential. And again, just coming back to my own biography, a lot of my research has been precisely on this, how to think about econometric practice under rational expectations. Okay, there was also the issue that these models at the beginning were being rejected by the data, and traditional statistics says if the model is rejected by the data, then don't use it, but then the consequence is, well, but I know that my model will eventually be rejected by the data because it's just an approximation to the reality. That doesn't mean that I should never use a model. And that's what forced people like Sargent and Lars Peter Hansen and many others, including very modestly myself, to think about what does it mean to do or to perform statistical inference in those type of environments. Now, the rational expectations route was not the only possible route. There were others. One of them, for instance, was the development of vector autoregressions, and more precisely, structural vector autoregressions by people like Chris Sims, also at Minnesota. And what happened over there was basically the idea that what you could do is to specify a vector of variables and then just estimate how that vector of variables evolve as a function of its own past, and that will be flexible enough to capture the behavior of the economy. And that will get you around the problems of identification that plague traditional econometric models, like the old style models of the Keynesian tradition. And Chris made this point in, and again, an enormously influential paper, Macroeconomics and Reality, that I think, again, is one of the most cited papers of the last 50 years. On the other hand, you don't want to think about rational expectations and structural vector autoregressions as opposite routes, because in fact, you can show that every linear or linearized rational expectation model is also a vector autoregression, and that you can think about every vector autoregression as being backed up by a rational expectation model. They are really two sides of the same coin. And now, at the risk of sounding a little bit arrogant, let me show you a paper that I think that clarified this point to the profession very clearly, A, B, C's, and D's of understanding VRs, where I was lucky enough to be able to write this with Juan Rubio Ramirez, Tom Sarient, and Mark Watson. And this has helped us to understand much better that all fights that you may have heard back in the day about calibration was an approach that Ed Prescott and Fit Kidland proposed to get around some of the problems of the early generation of econometrics for rational expectation models, and the difficulties that involve versus traditional estimation is somewhat outdated. By now, we understand that calibration, which is just to select parameter values to match some moments of the data or to borrow from the literature from previous studies, is nothing more than a method of moments. Maybe done a little bit informally, and sometimes you don't really need to do it more formally than that because there is no point in achieving that extra rigor for no particular gain, but that at the end of the day, as I was saying before, really calibration and estimation are one and the same. And the last route that I want to discuss before wrapping up this section is how actually the rational expectation revolution muted or transformed itself into something different in the early 1980s. And basically the problem was that the attempts of people like Bob Lucas mainly, but also Sargent and Wallace, of creating theories of the business cycle were not very successful. Okay? And then Fiscal and Ed Prescott. Well, here you have Ed, for anyone who cares. Ed was the chair of my dissertation committee, and I'm looking at his photograph right now, not the one over here, but here in my office. And Finn Kitlan brought an enormously influential paper in 1982, Time to Build and Aggregate Fluctuations, where they show that you can take the stochastic neoclassical growth model, hit it with productivity shocks, and that model is actually going to be able to capture a lot of the behavior of the economy. Now, again, as before, this is often misinterpreted. Ed and Finn didn't want to think about negative technological shocks as technological regression or people forgetting. What they were basically thinking is, imagine that the economy is growing on a trend of technological improvement, but sometimes we improve more than average and sometimes we improve less than average. And that's what a negative technological shock is. This year, the new model of the iPhone is not much better than the previous year model, and that's a negative technological shock. And it implies an agent that is optimizing intertemporally is going to invest and consume less in that situation than otherwise. But the real enormous importance of the real business cycle model not only is that it really accounts for a large chunk of the aggregate fluctuations, but that it turned out to be the case that it was like a Lego kit, one of those kits that you give to kids. And it's a model that is enormously easy to add with extra features. And by adding those extra features, basically nominal and real rigidities, you go to the modern dynamic stochastic general equilibrium models, which is nothing more than the stochastic neoclassical growth model with a lot of market imperfections. And the people who work on that were John Taylor, Guillermo Calvo, Greg Mankiw, Mike Woodford, among many others that I don't have time here to cite. And for instance, there was a couple of volumes of Neo-Keynesian economics that introduced a lot of that research. I read them in my last year as an undergrad, both books very religiously. I learned a lot, helped me a lot when I came to graduate school. And much later, Mike Woodford, I think 2001, 2002, published Interest and Prices, which summarize the state of the knowledge about Neo-Keynesian models. These DSGE models also came known as Neo-Keynesian, somewhat confusedly, because they are different from the Neo-Keynesian of the 1960s, but somehow they came known as Neo-Keynesian models. And this book by Mike Woodford really summarizes that research very nicely. And the last route that I want to mention is growth. And basically, a lot of people came to the conclusion that the profession was spending an inordinate amount of time on the business cycles, but at the end of the day, aggregate fluctuations were not that important, and that we wanted to deal a little bit more with what really matters in the long run. In the way that Bob Lucas put it, once you start thinking about these issues, it's very difficult to think about anything else. And that was important because the big boom of growth theory of Solow, Cass, and Koopmans in the late 1950s and early 1960s had somehow became stale. And then you have the growth and the appearance of a modern endogenous growth theory that tried to think not only about the possibilities of increasing returns to scale, but also about increasing varieties and the introduction of new goods. And what I think by Romer, who is over here and got the Nobel Prize, and what I think, in fact, is going to be more long-lasting in the very long run, which is Schumpeterian growth, which is the idea that really tries to capture Schumpeter's insight about creative and destruction. And Philippe Aghion over here and Peter Hobbit over here were able to set up that model. And again, as in the case of the DSGE model or the basic RBC model, it has the enormous advantage that it's very easy to build on that model and to get further insights. Again, coming back to my own life, last week also, not only I presented a modern DSGE model with heterogeneous agents and the MBR Summer Institute, the day before I presented another model, which is a Schumpeterian growth model. And the papers where this was introduced was Endogenous Technological Change by Paul Romer and a model of growth through creative destruction by Philippe and Peter. Let me wrap up over here. There are many other developments in other fields, and I have skipped some of the more recent ideas, like telling you more about heterogeneous agent models and machine learning. But suffice it to say that economics as a whole has changed deeply since the 1970s. It's a very, very different field, and that I would really wish that a lot of people who are not experts on the field are able to communicate to the profession at large and to interested observers outside economics that this is in fact the case, because I think that will help a lot with having a better conversation about making better economic policy. So let me stop over here and we can open for a few questions.
Great, thank you, Professor Jesus. So we're open for questions. Let's start with the first one, which applies to the first slides. Has the push toward data and empirics taken economics so far that we are just doing applied stats now and not really asking economic questions anymore?
Yes, unfortunately, I'm on the side of that view. I think that introducing data is fantastic, and I'm the first one who uses data. But at the end of the day, I think that if you look at a lot of the recent working papers over the last 5 years, there is an overrepresentation of working papers that deal with topics that are perhaps not that important, and yet you have good data to deal with them. And that seems to me a little bit silly and not the best allocation. Moreover, I think there was something called, I mentioned it quickly, but just in passing, called the credibility revolution, that basically emphasize having clean, sharp identification. And what I think it has happened at this moment is that many papers care more about having a clear and sharp identification than in dealing with important questions. And personally, and I'm sorry to be a little bit critical, I think this is particularly true in much of development economics and applied microeconomics. I see many, many papers about topics that I don't think are very important, but where you have clear and sharp identification. So yes, I think that as much as I like data, and I will call myself an econometrician to a large extent, I think that we have overdone it a little bit.
A follow-up question on that, methodological aspects. Has the rise of math in economics widened the gap between the profession and the public? It often feels like economics and lay people are talking about entirely different things.
Yes, yes, no, most definitely. I mentioned it when I was talking about how I often talk with people who are trying to do history of economic thought, and you can tell, sorry, I hope that Andre doesn't look at me with hate, but that sometimes I feel that they just didn't get the point. At a very fundamental level, they didn't understand the math that we were using and that they were missing the point. Yes, this is unfortunate, but I also think that this is something that can be fixed. I really think that at the end of the day, if my strong belief is that if you cannot explain what the math does in a way that is intuitive and that someone who is willing to listen for you for 10 minutes can understand, you are failing. Okay? And if you talk with the really top people in the profession, they can always explain things in an intuitive way. And I think that the profession should reward more those who try to make an effort at communicating with the general public the insights of economics, and that we don't have good institutional setups to do that. It's much better for most people to publish one more paper in the American Economic Review that try to explain some basic and fundamental results in the profession.
Now, question by Ioannis. Do you think game theory instead of general equilibrium could serve as the fundamental micro-foundation for workhorse macroeconomic theory?
Which theory?
A game theory.
Well, I will not really put game theory and general equilibrium as opposites. General equilibrium is just an environment where there is a lot of players and their strategic impact is small. And I think there are questions for which thinking about strategic interactions is very important. So, for instance, I was mentioning before all the models related with time inconsistency. A very natural way to think about time inconsistency is as a game that is set up between a government and the agents in the economy, and you have two players. And there are questions that are more meaningfully posed in terms of general equilibrium. So, my view about this is that economics offers you a toolbox, and that the success of a good researcher is to understand which is the tool that you need to use in this particular problem. And I'm not going to make in any moment a fetishism out of one particular choice or another. This is not religion.
In a similar question says, some argue that macroeconomics shouldn't not be macro-founded on expectations at all, but approach holistically as an underdetermined system. I've seen physicists deeply trained in advanced mathematics that have been quite critical of the field. They precisely claim that economists are undertrained in math and therefore misunderstand complex systems. What's your take on that criticism and the broader idea that macro should be studied as a system in its own right?
I basically think that everything over there is bullshit. Sorry to say it that clear. Okay, so I dealt with a fair amount of physicists and engineers. First of all, I will seriously doubt the statement that physicists know more math than a top economist because it's just not true. Okay, there is a very famous anecdote. This is the Santa Fe Institute. This is the people talking about, complex system, blah, 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 blah. Anyway, so they have the first meeting. And the physicist had this very arrogant view, oh, we are very smart, blah, 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 blah. And one physicist, I'm not going to say his name, he wakes up and sets up a problem of dynamics and says, well, this is so deep and we don't really know how to characterize it. And then William Brock, I don't know if anyone has met William Brock, but believe me, William Brock is a smart guy, raises his hand. He's an economist. And he says, I know how to prove that. And he wakes up, goes to the whiteboard, picks a chalk, and actually proves the theorem. Apparently, Mike Woodford and Michele Boldrin were in that meeting, and those were the ones who told me. Apparently, the attitude of the physicists dramatically changed after that moment. Okay, so to begin with, no, I'm sorry. And by the way, I took quite advanced math in Minnesota in graduate school, and sorry to tell you, but economists always got better grades in the final math exam than the physicists. Okay, there was a guy called Karsten Jeske, and Karsten Jeske was systematically #1 in every single exam. But coming back to the point, look, physics and economics are inherently different issues or inherently different areas of research. If I'm going to look at an electron, the electron does not care about what I think about him. And the electron does not care about whether or not I'm going to still run this experiment tomorrow. The electron is going to do whatever the electron is going to do. In economics, monetary policy depends on what the agents think the central bank will do 5 years from tomorrow. An interest rate increase that is part of a systematic rule of interest rate increases will have a very different implication than the very same interest rate increase, which is not part of that systematic rule. Because agents understand what is happening. Okay? Tom Sargent, in one of his books, Rational Expectations and Inflation, has a great example using American football and how a quarterback will throw in different ways if you are in the first quarter of the game or in the last quarter of the game. And that's why, in general, my experience has been that whenever I have talked with physicists and engineers, since they miss this fundamental point, what they tell me is usually useless. And they have been around forever. I'm a little bit older than you guys. I have seen these people doing econophysics since the early 1990s. Have we really learned anything from econophysics?
No. Argeno asks, do you share or on the contrary disagree with the critical view expressed by Robert Heilbronner and William Melberg that there is a crisis in modern economic theory, especially due to its formalism and lack of an integrative vision?
Okay, I think I can answer to that the same point I was mentioning before when I was talking about Keynes and Murray Rothbard. When did Heilbronner died? Probably like a long time ago. Okay, so what can Heilbronner tell me about what I think are the super exciting papers I was showing you from the 1980s and 1990s? And to be honest, I really don't understand what integrative means. I don't know how many people have taken a class in analytic philosophy, but those are very useful classes because you will walk into the class and what they do in analytic philosophy is they really force you to think about the definition of your concepts. What does integrative mean? Sounds great, or holistic. I go to many meetings in the university, and they always tell me we need to have a holistic approach to education. And I always raise my hand and I say, define holistic. And I never get a very good answer. Now, do I think everything is perfect in economics? No, I was very critical, for instance, about many things before. I don't think these are very deep criticisms. I just think that criticisms that sound great, but once you sit down and try to analyze what they really mean, there is actually not much behind them.
Tying the philosophical aspect, there's a question about that. Ioannis asks, what do economists mean when they say a model explains an economic phenomenon? What is exactly a macroeconomic explanation?
Well, actually, I rarely say the word explain. I usually use the expression accounts for, which makes the point that these are two different things. I have a model that generates a behavior that is somewhat similar to what I observe in the data. And that changes. I'm going to think about this from a perspective of Bayesian epistemology. I have a model of the world and a theoretical model. And when the theoretical model replicates some observations that I see in the real world, that helps me to change my model of the world in the direction that the mechanisms that really drive actually observe data are somewhat linked with the mechanisms highlighted by my model. So if I have a model, a theoretical model that says that systematic changes in the interest rate rule have systematic effects of inflation, and I am the central banker, this is going to change my posterior belief about my capability as a central banker to influence inflation. So I will rarely say that a model explains a phenomenon. I will always say a model accounts for a phenomenon.
Now, going back to the question of the credibility revolution empirics, Leonardo asks, can we use in macro the idea of credibility given that everything is endogenous? We don't want to perfectly identify nonsense.
Exactly. So my view of the world is the following. I'm going to come back to the point I was saying before. Look, there is an old tradition that goes back to Marshak, that you want to think about the estimator as something that is going to help you to understand something important about the world. If it happens to be the case that your estimator is cleanly identified, or you can design a research setup that gives you clean identification, that will change your posterior a lot. If you cannot do that, you will change your posterior a little bit less. Okay? That's why, for instance, if you put me against the wall and you tell me, are you 100% convinced that monetary policy is very important for output fluctuations? I will say no. It's probably a 60% convinced, 70% convinced, but I don't have the type of metaphysical conviction that a physicist will have about the laws of quantum mechanics. Now, what I think has happened is that quite a few people have decided to stop working on important issues that are not very clearly identified to work on irrelevant issues that are clearly identified. And that's not good. So again, I'm not against clean identification. Clean identification is good. But like everything, economics is about trade-offs. And what you cannot say is I'm going to have a lexicographic preference for identification. So the way I yoke this is that the average paper you will see today in many places is, we are going to get 10,000 students. To 5,000 students, we are going to give them a blue eraser. To 5,000 students, we are going to give them a red eraser. And guess what? After 1 year, students that have used the red eraser do 0.00001% better in a standardized test, because it's slightly easier for them to pick the red eraser, and then it increases their incentives to rethink their answers to the test. Okay, fine. And that's clearly identified, and it may be statistically significant. And we learn what? We learn what? Okay, let me put it in another way. If you run a regression on the head count of poverty in a country against the income per capita, the correlation is 0.99. Okay, basically says that how many poor people you have depends on your income per capita. If you want to reduce poverty, what you need is that a country grows. Everything is irrelevant. Development economics, or most of modern development economics, is about reducing poverty with things like we are going to give people malaria nets, or we are going to be sure that teachers show up to class in small rural communities. Guess what? We are trying to identify the 1%. Okay, we are just trying to make the 1% a little bit smaller. No, man, you don't want to care about, making the lives of people a little bit better because they have malaria nets. You want to understand why Singapore grew and Tanzania did not. That's where the real money is. And unfortunately, writing papers about why Singapore grew and Tanzania didn't have a much harder time being published that, oh, guess what? If we give students in Tanzania red erasers, they are going to do slightly better. And on that, I'm very critical.
Now I'm going to merge two questions about expectations of the modeling of expectations. What about grounding economic models of expectations in psychological theories of human behavior, something neither ad hoc nor based on perfect rationality? And the second, which is how do you reconcile rational expectations with financial crisis?
Okay. Let me start with the second because it's the easier. There's nothing about rational expectations that implies you cannot have financial crisis. Okay, just talk with Eugene Fama, he will make that point repeatedly. Rational expectations is only saying that there is no way you can forecast systematically a financial crisis. Okay, it's trivial to build models of rational expectations with financial crisis. We know that at least since David Krebs' 1979 Journal of Economic Theory. So there is no need to reconcile rational expectations with financial crisis. It's perfectly fine. There are 20,000 papers published with rational expectations and financial crisis. Okay, let's go back to the first question. I'm very open to that idea. I'm very open to the idea that we can think about psychology, we can think about neuroscience, and have better and more sophisticated models of how people build expectations. Many smart people have been working on that. The success has been limited. I don't think it's limited because the idea is flawed. I think it's limited because it's very difficult. But one of the persons I admire the most in the profession, Mike Woodford, is now spending a lot of time thinking about that. And if I've learned something in this profession is that every time that Mike Woodford and I disagree on a topic on research, in every single occasion, time vindicated Mike and corrected me. So yes, I think that's a very good idea. Now it's very hard. That's going back to the point about credibility. The problem is that the really important problems are very hard to work on.
Carles asks, what do you think will be the major themes studied in History of Economic Thought course when examining the work of economists in the 21st century?
Oof, I wish I knew because that will mean I will be over there doing it myself and writing those papers. I think that if I were going to write a history of the last 25 years, remember I stopped around circa 2000. If I were going to push to 2025, the credibility revolution that needs to be up and forefront, the strengths and the weaknesses. Again, I don't want to sound too negative about the credibility revolution. I would say that 75% of the credibility revolution was good. I think we just took it a little bit too far. So trying to understand the credibility revolution, I think everything related with political economy, the fact that suddenly I think that more than ever economists are aware that there is a feedback loop between the political system and the economic system and that we want to understand it very much better. And from a very selfish perspective, I think that heterogeneous agent models are really, really going to change. And they have already changed the way we think about many, many problems.
Now, a final question, broad question about the course, generally speaking, says, I ask you, why are there fewer and fewer courses on the history of economic thought at undergraduate and graduate levels in economics faculties, given the importance of it?
Well, so first of all, let me answer this question at the normative level. I fully agree. If it were up to me, I think this should be a course. I don't know if I want to make it compulsory for all the students, but certainly should be elective. And well, both Fernando and Andre know that this course exists at Penn, and they teach it because I made it so. So you don't need to convince me. Personally, I think this is a consequence of two reasons. One is pragmatic. There are so many things to learn in economics. There are so few, and there is so little time, that people have made choices, and I think that sometimes those choices may not be ideal. And one of them may be, learning like one more estimator instead of learning more about history of economic thought. I think that maybe learning a little bit more about history of economic thought could be more important. But I also think that part of it is the flow of the field. And I think this has come up several times today. As I was mentioning before, I was just looking at my library on Sunday as I was preparing my slides, and I was looking at some of the books that people wrote about the rational expectation revolution. They are really bad. They are really, really bad. And I think that this is a field that needs to confront that. If you want to say something interesting about heterogeneous agent models, you need to learn about heterogeneous agent models. And I read a lot of what people write about heterogeneous agent models, and I say, if you answer that in an exam, you will fail. And when I tell them to those practitioners, they don't believe me.
Well, I think we've reached the end of the course. Thank you everyone for attending the whole month and a half. Thank you, Professor Jesus. Thank you, Andre and Ivan, and those that presented. And well, maybe see you next year and next theme, which we don't yet know.
But we have an idea. We have some
An
hints.
idea.
Okay.
Okay. Well,
Yeah, look at the calendar and take 250 years out.